All good. Can people hear me okay? Yeah, up the back, all good? Cool. Okay, the topic that was on the agenda was like its failover thing between Aeolus and OpenStack, but we're integrating another product with it at the moment, so the code's all busted. So if you went to go and try it, it wouldn't work. So instead, we're doing introduction to OpenStack. Some of you guys, well, this is related, so hopefully good. So who am I? I switched across from the Aeolus team about a month ago to a new team called the Open Source and Standards team inside Red Hat. I work in community building roles. I'm a software engineer, so I work on the technical side of stuff. At the moment, I'm working on GlusterFS and integrating it with OpenStack. So thus, the OpenStack knowledge that I've got, when you guys ask questions, it will be more on the storage side. I'll be able to answer. If you ask me questions about the in-depth quantum side, which is the networking, I'll say just email me and I'll get back to you then, right? So that's my knowledge space. Also, feel free to email me anytime. I will get back to you with answers and stuff like that. So, how many people here have used or looked at OpenStack before? Cool. There's about, 5 of you guys? Out of curiosity, have you guys looked at the RDO thing yet that was launched yesterday? No? Yes? Yep. Okay, yeah. The guy that works for Red Hat, yeah. So, all good. Okay. Part of this topic will cover a thing called RDO towards the end of it. Several of the people here have looked at OpenStack. Some of you guys haven't. It's a cloud software. Red Hat yesterday launched a community version of that specifically for enterprise Linuxes, like, CentOS specifically, CentOS and other things. We'll cover that towards the end. That's a community support, not like, we'll support people, running community versions with cost. So this OpenStack thing, what is it all about? It's a ecosystem and a large group of companies all coming together to make an effectively open source version of clone of EC2, Amazon type of thing. I say type of thing a lot. Open source version of it, but improved, So we get all these different companies like Citrix, HP, NetApp, various other things. And unlike EC2, which is a proprietary closed ecosystem and they do its own thing, places like NetApp, IBM and others who have their own, let's say, storage systems or their own proprietary way of doing stuff that want to get into massive scale operations, these places get involved with OpenStack because they can write drivers for themselves and have support for their own products in it. So you'll find that all this list of places over here is heavily involved in OpenStack, and there's drivers supporting everything. So this is what a view from the clouds. So rough view from the clouds. So looking down from the clouds about what OpenStack is for people that want to build public and private clouds. It's unlike overt or Rev type of products, which are like an equivalent to VMware and very, very good competitors to VMware. This is purely a project that is made for massive scale-out type stuff. It's not something that you actually would want to deploy in a small business on 2 or 3 servers and expect that to be a production type of thing. You don't do that. This is really targeted at 100 plus servers to get started. You can run it smaller, but it's not really what it's targeted for. It gives the illusion of infinite resources. Its viewpoint is, from an end user's point of view, there's as much of this as they could ever use. From a systems administrator on the back end, you'll be monitoring the hell out of it and actually you'll be aware of what's actually there. So that, there is a difference. It doesn't just pretend totally or badly. One of the really good things about things like OpenStack, when it's done well, the person says, launch image, and a few seconds later, it's there, it's ready. It's very, very fast provisioning. If you've ever worked in companies like IBM or things where they go, we need to deploy a new server, and here's the form about how to get it done, and you do all the paperwork and you submit it and it goes through the chain. 3 weeks later, you might get a box if something hasn't gone wrong with it. I've worked in places like IBM and in their rapid provisioning teams and things, which take 3 weeks for a rapid provisioning. Painful. This is like we've probably all used on the internet, almost like running a virtual machine on your laptop. This is the cloud version of doing that. One of the really good things about OpenStack, which a lot of projects don't have, is it started out practically with APIs for everything. So you've got command line tools for doing everything, but you've got REST-based APIs as well. So if you happen to be a programmer or coder or a scripter or anything like that, and you don't like doing stuff always from the command line, or you want to automate it, there's APIs for everything. So if you want to build your own command line interface, use the APIs. It's very API-driven, command line interface-driven. It's extremely customizable. How many people here, out of curiosity, know Python? Anyone here Python? Okay. OpenStack's written in Python. So if you happen to be a dude that wants to go, yeah, it's good. Is anyone familiar with Django? Yep. Okay, Django person as well. Do you do stuff with OpenStack already? No? Yeah? Okay. Well, guess what? You're in luck, because OpenStack is written in Python and there's a web interface for it called Horizon, written in Django. So like Django 1.4. Most of the logic in OpenStack, when you look at the web interface, most of the Horizon, this web interface part, is all very modular. When you see the screenshots later on, they all look very bland and very basic. So you'll have the information, and it's not flash, it's not whiz, it doesn't look super nifty and shiny and that sort of stuff. It's functional. But the modular bits with Django is so someone that actually knows their shit can actually go in, look at it and go, oh, we can make shiny buttons. It's made to be extensible. Part of this whole, here's your building blocks, go and do it sort of thing. Yeah, so OpenStack core services. Sorry, I get off topic a lot. So if anyone has questions, you actually just go, Justin, here's the question. I'm good with that, okay? So I'm not one of these wait till the end type of speakers. Is that cool with everyone? Yeah? Am I speaking too fast? Can everybody understand me? What? This is the what? Dutch crowd? Oops. So, yeah.
You are right.
So, yeah. Well, there you go. I have a habit of speaking too fast in personal life, and when I get into things, I speak fast. So, if I do that, tell me to slow down, because I will. It's just personal thing, Now, OpenStack core services. What this is trying to illustrate is you've got this central sort of thing that presents OpenStack, this cloudy sort of thing. You have a bunch of nodes, which are actually your servers, and these nodes do things like compute node, which, is everyone here familiar with EC2? Yep, EC2, Amazon, have used. Okay, I'll say show of hands. Has anyone actually used it? Cool, okay. We have 3-4 people, sweet. Okay, it's a start. Yeah, so I'll get into the project breakdown later on and what the individual parts are, but it's a normal everyday sort of cloud virtualization type thing. You have your, this is the cloud and the ways to access it. This is showing that you have your OpenStack web interface. There are screenshots later, so that's this, boring sort of thing that's, extremely customizable Django sort of stuff. You've got your REST API to access the different parts of it, which is, normal. And yeah, you've got all the back-end stuff that just hooks into it. Nodes being just, the servers that you have hooked up, normal everyday server sort of stuff. A bunch of components we'll go into at the moment. One of the core things to think about with OpenStack is like Lego blocks. You've got all these different components, and when you see the diagrams later on, it's not a simple structure. It's really, things are everywhere. It's a cloud service. It's not, it's not simple when you actually get into development for this thing of what does what. If you're like me and you're in the storage sort of stuff, like I'm very focused on the whole Cinder thing recently, just because that's, what my work involves. And I can't tell you jack about how the fundamentals of Quantum, being the networking service, works. You'll find that if you get into the OpenStack thing, you'll get a broad overview quickly, and then whatever the interesting part that you find is, you'll get into that, and it'll be optional later on if you get into the other stuff. It's just, most open source projects are like this, so don't expect it to be any different. OpenStack's point of view, though, is it's all made from the design to be like Lego blocks. And this is why so many external companies are involved in this, because You've got these APIs that everything follows. You've got these command line tools that use the APIs, and you've got this web interface that also uses the APIs. So these companies come along, they go, wow, for example, NetApp, just as an example, so this is purely example, okay? So a company like NetApp comes along and says, wow, we can rip out this component, put our own component in there. You know, NetApp, of course, being very fast storage for NAS type stuff. And you know, as long as we have an interface that does the APIs, completely transparent, works well. It's so yeah, a lot of people come along, they have their own products, and they think, we can rip our XYZ component, shove our own in there, and as long as our component has like this API and answers the APIs properly, totally transparent. So if you guys want to get into OpenStack development at all, as a thought, that's how you do it. You know, identify the component, get your own instead. You know, make sure your API works with it, and voila, that'll work. Then you try and get it upstream. So if you've got an open source project, you know, that it does something like, you know, storage, networking, or whatever, then you get it upstream, and voila, you've got support in OpenStack. You know, use it on the marketing material. Make sense? Cool. Yeah, so that's what every company's done in the short form. You know, with some differences. I generalize a lot, right? So don't get too stressed about that. Yeah, so what makes up OpenStack? You've got a thing that spins up the VMs, which is Nova. That's Nova, which spins up actual virtual machines. Compute node. That's the equivalent to EC2 in Amazon. You've got Glance, which is like it's sort of like a metadata service. It's hard to sort of describe that in an accurate way, other than saying that Nova talks to it and actually gets virtual machine images from it and puts other metadata to do with virtual machines and other things in this Glance thing. And yeah, so it's sort of like a metadata server. All of these are, by the way, extremely replicated, extremely distributed, and broken up into tons of little components. You can put each component on individual servers and scale them out too. So this is a simple sort of diagram, but the actual implementation can get kind of tricky, which, you know, this thing I'll show you later simplifies it. So we've got Nova, the compute. We've got Glance, which is the metadata. Swift is like an object storage. It's kind of like, if people are familiar with S3 in Amazon, it's where, you know, you have this container, you put files and other objects that you want. You can't create a directory structure as well. You can't mount a directory structure, even though you can create manually a tree structure. But just think, if you're familiar with S3, that's what Swift is. The actual implementation is an extremely distributed, extremely replicated file system, basically. You know, it's fairly rugged, but, you know, it's reputation for being a bit of a pain in the ass, just saying. You know, lots of file systems are. Quantum, plug-and-play networking, apparently. I don't know much about this just because I have not personally yet touched this, but it's software-defined networking is a buzzword people are using these days. That's got something to do with it. That's all I know. So if that makes sense. Cinder, volume service. If you guys are familiar with elastic block storage in Amazon, which is purely large-scale files, like, you know, image files of, like, when I say image files, I mean, like, you know, your 20 gigabyte sort of virtual machine image files or additional storage. None of these 2K, 3K, 4K files. Cinder is made for, you know, fast giving of large block objects. Keystone is an authentication and identity service. So anyone here ever used a thing like OpenID? Yep, cool. Okay, if I ask a question, guys, and if instead of nodding, because my eyesight sucks, so if I ask a question and say, hey, have you, yeah, exactly like that. So, does that make sense?
Yep, I do.
Okay, so 2 people are still listening. Fuck. So, anyway, yeah, so Keystone is something that ties into everything. Anytime you want to access a service, Keystone is your authentication mechanism. You know, every request through an API, through everything, Keystone. Via the command line, goes through Keystone. So when you implement anything, Keystone is one of the very first things you get up and running, because without it, everything's not there, right? Nothing will talk to each other. And the web user interface is called Horizon. Dashboard, this simplistic sort of stuff, screenshots later. Okay, and I've just gone through the entire slide deck. verbally. So we'll probably just skip forward a few. So the Nova thing. This is Nova. Like I said, the whole thing is really super complex. This is the first component, right? So has anyone here used message bus type stuff like AMQP type things? Yeah. Okay, yeah. Good. Yeah, you guys are like, you seem to be on the right track to just slot into the whole OpenStack thing very, very easily. Pretty much everything communicates inside OpenStack via message bus type stuff, just because it's ordered messages. And once you've got one of these things running, you just push everything at it, it takes care of that sort of stuff. I've had experience in other projects before that didn't use that approach, trying to do publish, subscriber type things and all sorts of stuff. Painful. This approach is, much cleaner, much more scalable, and you can, in theory, you're supposed to be able to put in any kind of message bus. I don't know that anyone's actually doing that. I mean, I think the terms RabbitMQ, I think, is in there, as well as AMQP, and it's not something I've ever touched personally that much yet. I've seen it at a distance, so if you're into that kind of stuff, look at that type of stuff as well. So who here has used libvirt before, or seen or heard of libvirt? Yeah? Got the hands happening, cool, yeah. Okay, no, this is a good thing, So libvirt and KVM, pretty much, you guys that have touched libvirt have probably looked at libvirt and KVM. So that's like, running on Linux type stuff. The compute start for spinning up virtual machines uses libvirt in the background and KVM in the background. They're not the only hypervisor technologies that can be used, but by default, especially if you download the Red Hat version of this free community thing for CentOS, you're going to be running, of course, KVM, right? It's not going to let you hook into Hyper-V so easily. I mean, it probably would if you try, but it's not built for that, right? Now, the point is, if you're familiar with libvirt, when you start up a virtual machine in any of these, if you're familiar with Virtual Machine Manager and you just happen to start that up, you'll see all your virtual machines running in that as well. So it uses on the back end of OpenStack technologies that you're familiar with. It can also use things like Overt or Rev. If the Red Hat guy up the back is listening, no, he's not. He's completely, he's working, it's okay. So, no, it's all good. So, yeah, okay. So Red Hat's a relaxed company to work for, I'll say. So it's all good. So it doesn't have to use libvirt and that. It can use things like Overt and Rev, but by default, most things you'll see will run.
Can I use Aeolus as Rev? Because I think it's not possible at the moment.
Look, I've seen some guys that were talking about demoing it. Which means that they've, you'd be kind of hoping that the code was written when they said that. I don't know if it's upstream, but I know it's possible. And those particular guys, they were saying it in response to somebody else that wanted that feature. And so I would assume very strongly that that will be upstream in the code base, at some point in the near future. I mean, one thinks, Does that make sense? Mr. Overt guy over there? All good. You'll find with a lot of the OpenStack different components, this like storage component and this compute component, and many of them are broken up into the actual component that does the work. It's like if you do like a check config from a RHEL box or CentOS box, you'll see like a list of services, and you'll see the component name, like OpenStack-Cinder-volume is the actual thing that does the work for that particular purpose. You'll also see like a scheduler version of everything. So OpenStack Cinder, as an example, has OpenStack Cinder Scheduler. You'll see an API, different service again. So most of the services that are part of OpenStack have like an API, scheduler, and they're separate daemons. So when you do a check config, you get this huge ass list of different services. Pain in the ass if you have to manually sort of start and stop everything. You will script that yourself. So Glance is this metadata thing. It's because OpenStack is so made with so many different companies hooking in, it's just following this API thing. The backends that you can use for most of these things, it just depends on what vendors and what open source projects have contributed stuff. So the backend for Glance is usually Swift, but it doesn't have to be. So you can use Gloucester as an example as a backend, although I haven't written it there. the glance for the image things supports all different types of files, file formats. So you've got your raw files. If you just, you make your disk, that's it. No special compression, no special format. It's just done. You've got your QCOW2, you've got your VMware, you've got your Microsoft, you've got your ISOs. Most people will be familiar with that, and your AMIs. I don't know so much about AKIs. I'm guessing it's something to do with Amazon. So some of you guys might know. And your OVF format as well. Glance, it can be used for it's because it's an image store. Well, because it's a metadata store, it could be used for private and public sort of stuff, but yeah, not a big detail. You guys will figure it out when and if you try this, by the way, which you should. You'll find that actually trying this stuff out is super straightforward. Image service glance, yeah. Okay, Swift, similar to Amazon S3. Like things like Ceph, like things like Gluster, it's made for commodity hardware. Unlike Gluster, it's a bit of a pain. It's got a reputation for all good when it's all scripted and stuff. More interesting if things go wrong. Haven't touched it myself much yet, so this could just be impressions of people that have told me. So, it's made for scale-out type things as well. So, just plug in more servers and it'll take care of most of the operations as you add more boxes. It's just, it's... Has anyone here used Ceph? Cool. Yeah, cool. Yeah, no, it's all good. I mean, if there's a crowd that's got, knowledge. I haven't touched Ceph myself, but it's got a reputation for extremely good performance in certain situations, but you really have to know the knobs to tweak. Is that an accurate way of looking at it, or is it just works?
Basically, it just works.
Cool, okay. In that case, you might want to see if there's a backend for, if you do this, you might want to see if there's a Ceph backend. I'll just put a plug in now. The Gluster FS actually works like that too. It just works normally. So, I do stuff with Gluster, so, I haven't touched Ceph yet, so thus the question. Moving along, let's see. Yeah, like most of the services, it's an API thing, and there's the actual part which does stuff. So in OpenStack, again, API daemon for practically every individual service, and there's something behind it, this daemon behind it which actually does the work, with schedulers in between to actually say which node gets what. Dashboard. This is the Horizon web interface. Modular Django web application, as mentioned before, so if you want to get it and make a knockoff clone of OpenStack, go right ahead, honestly. With pretty interface, rebadge it or whatever, it's all cool. It's made for doing that. You're quite welcome to. Provides end user and administrator user interface, which is why it hooks into Keystone for authentication. So the same web-based interface, you can swap between admin user and normal user, but you have to sign out, sign in. It all looks the same for normal users and admin users. And plug-in architecture, so other projects can add their... Actually, that's probably sounding better now, yeah? Okay. Plug-in architecture, so if you happen to have your own open source project or own company and you've added support to it in the APIs and scheduler, you can also add support to it through the actual Horizon web interface. If you happen to be doing stuff with an open source project that you'd like it, you would like full support in, you can contribute upstream that modular part and actually have it included in main OpenStack as well. Places like NetApp have done similar, as long as the drivers and the widget bits that they do are open source, because obviously all the code for this is open source. So as a curiosity question, how many people here are from doing stuff with an open source project? Are there anybody here involved in their own open source projects? Okay, yeah, cool. Okay, so is anybody here from a company that's thinking maybe they could get their product into OpenStack or something if it was the right fit? Okay, well, so all you guys are potential people that could get your thing into OpenStack, whatever your thing happens to be, if it makes sense to. Massive amount of media and publicity, of course, around OpenStack, so that's a plus. And you get tons of really, really, really professional coders to review people's code and look over it because everything is reviewed by a bunch of people. But your product has to be good. Does it make sense? So, so hopefully everyone's products here are actually rigid and useful for wider community. So this is the non-super fancy looking web interface. I tried to get a live running demo before, but trying to get a bridged connection on a wireless isn't such a happening thing. So yeah, no live demo. It's just going to be screenshots. Sorry, but yeah. So this is the Horizon web interface. I think everyone can say that we've all seen prettier web interfaces in our lives. However, it is completely functional. So it's minimalistic, and for people that want to customize it, it's actually easy to do so. Some of the commercial places that provide OpenStack, if you go and look at their web interface after you've seen this, you can see whether they've actually done exactly that, and they've made these quite pretty web interfaces that actually look pretty cool. And you wouldn't, if you didn't know any better, you wouldn't know it was something that they've just made it all, whiz-bang, just out of this common sort of framework with their own extensions. Instances and snapshots page, yeah, everything is just, like standard way of looking at things, menu left-hand side, individual type of, individual items to do stuff with on the right-hand side. Yeah, I'm over here to get a different perspective. Different people asleep? No? Yeah? So, it's cool. Yeah, so images and snapshots, it's all good. Basic web interface. And Keystone, the identity service. It's token-based, like everything else, pluggable backends for everything. So you've got SQL, PAM, LDAP, key value stores, tons of different things, depends upon what you want in your environment. If you've got an environment that wants to do, for example, Active Directory, it wouldn't surprise me if there was an Active Directory plugin. If not, and you want to write one, go for it,
They support that originally. It doesn't have to support for Active Directory.
Well, there you go. So, yeah, see, it's good that there are people in the audience that actually know this sort of stuff. So if I raise a dumb point, they can say, actually, it's all cool. So yeah, now, Keystone provides service catalogs and endpoints. What that means is when Keystone starts up, it has its own internal list of what parts of OpenStack should be available to it. So whenever you start up an OpenStack server, let's say, if you start up, for example, the OpenStack all-in-one server, which is this super simplified installation approach you'll see later on. When you start that up, it's got a whole bunch of services you would see, if you do check config, Cinder, Nova, and all the different parts of that. Whenever they start up, what they will do is they'll all try and talk to Keystone and say, hey, I'm here, I'm available. And they do that in a loop. As uncomplicated as that is, it's because it's a real pain in the ass to have to guarantee service order starts in a certain order and things break if they don't. It's just not the right way to do things, especially in an environment that's totally redundant, distributed, and supposed to be fault tolerant. So they just start up in a real simple repeat loop, practically every service that there is. So when Keystone finally starts up, these things will actually talk to it, authenticate and go, okay, I'm here. So your Cinder service will do that, your Cinder volume will do that, your Nova scheduler will do that, but they all do this sort of stuff. What that means is, after you've started up your box, give it a minute or so, everything's all talking happily to each other. In the in-between meantime, you're not quite sure what state things are as they start getting themselves hooked in. When you actually come to looking at this sort of stuff on a running box, don't get freaked out if in a log file you'll see an entry like cannot talk to Keystone service or cannot find whatever near the startup of a session. It just means it's doing its thing starting up. If you get a lot of them and they're still going, it's like can't talk to after half an hour, you've got a problem, right? That's the service you want to look at if there's something wrong. Yeah, so everything, it's a REST API for the API. There's catalogs, policy, identity, and tokens. Difficult to go into too much detail with this. I don't know each of these bits in a huge amount of detail at the moment. I just authenticate to the thing and it does what it does. Quantum. This is the bit that I am not real sure of. This is my area of weakness, and this is something I will get into soon. But this is, I know it uses libvirt for the libvirt type stuff, and it sets up virtual networks. So you can sort of say, via the API for this quantum thing, create network over here of this endpoint between these machines, and it magically does it. I don't know the details of how it does this, but apparently it's all good. If you guys happen to be into networking, you'll look at this and go, wow, what an idiot Justin was. It's so easy. Good luck to you, you know. But yeah, so has anyone here heard of Project Daylight? Yeah? No? Okay, the red hat guy in the back, yeah. It was recently announced like 2 or 3 days ago, this thing called Project Daylight. And who here has heard of software-defined networking? Okay, yeah, that's a few more. In the SDN space, this thing called Project Daylight, for the people that don't know, SDN is software-defined networking. It's kind of like this, it's hard to describe, it's kind of like this standard API you can write to that sort of says, I want my network to be like this, to make changes in your network, which at the moment, you know, you have to know vendor-specific things like Cisco and, Nortel, Juniper, specific ways of doing things for specific switches is my best understanding of it. The software-defined networking is trying to implement or provide a common API that you can sort of, talk to this API, and in the background, the software does it. The same API can actually be on switches. So you can actually talk to a switch via this API, and it does this configuration. So regardless of vendor, or even if you're using a software version of SDN type thing, it will, one API you talk to, and it takes care of the configuration that you want for the network. This Project Daylight was a bunch of companies sort of getting together and making an industry sort of forum about, okay, we're going to have a common protocol and a common working thing for doing this. Previously, the SDN has been startup companies generally, and a couple of big names trying to differentiate themselves from their competitors. And Project Daylight is like a vendor and project group that got together to actually do this in a better sort of way. Launched 2 days ago. You'll hear more about it over the next couple of weeks and months, I guess. So this SDN thing, Quantum provides the SDN layer, let's say, for OpenStack. Yeah. Has anyone else just noticed that I say quite a lot? Oh, I just did.
Just noticed cool.
Really? I'll notice that next. The other one is awesome and interesting, or the other two. So I can get most conversations done by awesome, interesting, cool, and yeah. Now, so Cinder, this is the block storage thing. This is the part that I'm most familiar with already, because of doing work with it. This is, good training for me. It's like, cool. When OpenStack first started up, or originally started up, one of the very first things to get up and running was its EC2 equivalent called Nova, which is what spins up virtual machines and does them according to whatever size. Because it's the first of the OpenStack components and the oldest, people kept adding features to it. It got hairy, complicated, like spaghetti type thing. So people that wanted to add new features to it, after some time, only the people that had been around for ages and knew all the bits, only they were able to really do it easily. So it became too complicated. So a few releases ago, they started thinking, we need to simplify this. So they've started on this path of making some of the components of Nova into their own sub-projects and breaking them out. Cinder is one such component. So in the most recent release of OpenStack, Cinder became a fully fledged component of its own. Nova still has the APIs and does the command line stuff that Cinder does, but it's like deprecated. It still will work, but things should use Cinder instead of the part of Nova that used to do that. And you'll see that this will happen for other projects in the future as well, as they break things out, the bits that are too complicated, and simplify them. So yeah, this provides block storage for instances. Yep, sorry.
You provide examples for that. So which components do you expect to be split out into their own projects in the future?
Good question. I'm not sure. Email me. Yeah? Cinder was one of them. I have seen mention of other ones. It's just at the moment, my brain isn't saying this is what they are. So, but I mean, a quick Google search will probably tell you. But if not, email me and I will get it back to you. I am the kind of person you can email and I will get it back to you. It won't be within 5 minutes, but whenever I wake up next and actually ask the right people the right questions and get it back to you. So my email address is at the bottom of every slide. The slides will go up on the website, I'm guessing. If not, Google search, you'll find it really easy. I am not a hard person to find via email and things. And of course, GlusterFS, which is the bit that I do, support was added for that in Grizzly. So there's a GlusterFS driver in Grizzly. There's also a Ceph driver for it in Grizzly, being the name of the latest release. Let's see. There is, up until now, with OpenStack, it's been a very, you spin up a virtual machine, you do your thing. If you need two virtual machines to all talk to each other, have dependencies on software that run together, it's been up to you to do that. You must put your own HA layer above or orchestration layer above that. Some of the guys that work for Red Hat did this, we're getting into this whole orchestration thing pretty heavily in one of our cloud projects. And they said, well, we could do that for OpenStack because OpenStack is written in Python. They know Python well. And what they were already doing was what some of the guys that already worked on OpenStack were sort of saying, we need something like this. So those guys put together a spec and then wrote a thing called Heat. Heat, it does orchestration and high availability for OpenStack. Apparently it's pretty good. I haven't tried it. I've seen demos of it, but I don't understand high availability quite yet. I understand orchestration. So has anyone here used WordPress at all? Does anyone here understand what WordPress is? Yeah, cool. Okay, yeah, cool. Okay, so just for the people that didn't put their hand up, it's WordPress is like blogging software. And if you set up a really super simple install of WordPress, it's like a web server and a database, like PHP type thing and MySQL type thing as examples. An example of what orchestration is about is when you set up one VM as a MySQL server, another VM as the web server, and you set up the configuration so they'll start up in the right order and they'll pass the right information to each other automatically. You don't need to do that manually via SSH scripts or anything. So for example, when you start up an OpenStack instance, same as if you've done this in EC2 or any of the other cloud providers, yeah?
It is the, what Ubuntu calls UU?
Similar sort of thing. I haven't yet touched UU, however it's pronounced. I don't know if it's UU. Yeah. I know the thing that you mean. They do some sort of orchestration type of thing. I would suspect it's something similar.
It is similar, but it's not really the same because UU is able to create some instances, but it is not able to talk to Cinder, etc. And OpenStack is talking to all the services you've got. That's the big benefit of it.
Interesting, cool. So we have someone that knows Heat, so it's all good. I haven't yet run it, so if I say something stupid, say, Justin, by the way. Okay, well, it's all good. So like all the other services, it uses an API, but the orchestration part is you can sort of say, okay, this instance needs to know, for example, the IP address of the other instance when it starts up. So for example, you'll have like a MySQL server startup, and OpenStack will give it an IP address, and it will need to be provided with a username and password, so that goes in the template or gets randomly generated, however you tell it to do it. But it can, when it knows its IP address, it can automatically provide that to the web server. And the web server will then start up and know to talk back to the MySQL instance. So they'll always start up in the right order, and you'll never get these 404-page can't be found type thing in your WordPress instance. So orchestration is about passing information between services and them knowing what should be where in what order. That hooks into the high availability part, is my understanding, because when one of those goes away, it makes another one, or something like that. I don't know the details, but you can find it out pretty easily. And they say that part of the way of doing that is by versioning. So, if you've got version 1 of your WordPress deployment out there, you can change things and make like version 2, and it will actually do it properly and not get confused. And so it understands the different versions of things that you put out there. Let's see, well-known templates and API. Has anyone used AWS CloudFormation at all? Yeah. Okay. Yeah. So that's the proprietary version of doing that. They've basically sort of looked at it and said we can do that better. So Heat actually copies their API. So if you have something that works to the AWS CloudFormation API or templates for it, you can use them with Heat, and it'll just convert them automagically, and it'll just work. Yeah. My understanding is. So that sort of goes under that. The Heat part sort of goes across everything and runs with all the other components. Has auto-scaling features too. I haven't touched that, but apparently if load gets high enough on the boxes at certain thresholds, it can spin up more instances automatically. I think that's pretty cool, as long as it knows how to spin them back down again. Apparently it does. In previous versions of OpenStack, not the one that was released like 2 weeks ago, Heat was incubation, sort of like I'll see if it gets popularity. It did, so it's now graduated out of incubation into a main OpenStack project. So this is a attempt to simply show you, this is the simple version of what OpenStack actually looks like and how the bits talk to each other. So you have like your dashboard, which is this horizon thing, talks to the object storage Cinder and network quantum. As you can see, that looks fairly complicated, yeah? Who here has memorized that already? Yeah, no one? Yeah?
Sorry, what?
Who here has memorized this already? Yeah.
I've seen this.
Yeah. That's all good.
One moment, please.
Yeah. Oh. Oh,
But I've seen the other picture as well.
This is the next picture. This is the slightly more accurate version, as in this is getting better. If you then drill into it more, which I don't have the picture for because this was just copied off the OpenStack website because it's an easy picture. But yeah, it is complicated software, so don't expect to jump in and just know all of it in depth in a day. The guys that do know things to that depth are very far and few between. Most of them work for Red Hat, I think, but not really. Many of them do. But when you get into it, you find your bit and you do it well. And that's normally how it goes. So who should use OpenStack? At the moment, has anyone here used any of the other major cloud sort of platforms, open source ones, like your OpenNebula, cool. Those guys are generally, they've been around longer. They've got, frameworks that do stuff. Some parts of them are more mature, this sort of stuff. It's all true. CloudStack is another competitor. What none of them seems to have is huge amount of uptake of developers. The community that I've seen around OpenStack is mind-blowingly moving forwards. It's a huge amount of commits, tons of people reviewing stuff, very engaged community of people. I used to do stuff with Postgres many, many years ago when it was starting to become really, really popular, doing, managing community sort of stuff for it. And there were times in that particular community where, for example, we got the .org domain name. The registrar that got .org started running Postgres and tons of press and marketing, went nuts. If they had Twitter, which they didn't back then, it would have just gone spastic. I was getting emails every 6 minutes, 24/7 for some time. This is the kind of thing, this is what OpenStack is like at the moment. And it seems to be, it's not even near its top. It's really full on. If you want to see a group of really passionate, enthusiastic people into OpenStack with extreme freaking tunnel vision, this is how you do it. You take a look at the OpenStack community. They are really active, like really, really active. It's not just all these companies. It's so many open source projects that have heard about it, that have their own thing, are going, wonder if we can use OpenStack, or wonder if we can integrate with OpenStack. It's because of the amount of marketing from various companies, it's amount of media and amount of change happening with it. It's like this self-propagating sort of thing. It's really steamrolling, frigging everything. But what that means is, if you want something and you're a small shop and you want to put it into production tomorrow, this is not the solution that you want. You want to find a mature solution that's been around your over or your rev if you want a small sort of setup. If you're a medium-sized shop or a larger sort of shop that is thinking, you know, okay, we've got staff, we can do this sort of stuff, we've got enough, you know, inbuilt resources to do this, and we want to build our own bits, or we're comfortable building our own bits, OpenStack is very much something that you want to be part of. It's just, you know, try it out, get familiar with it, make your own decisions. DevOps teams seem to like it because many places use Puppet extensively with it. Our super simple installation approach for the community version, you know, runs Puppet in the background. So, you know, it's manifests and everything. Let's see. The mandatory Red Hat mention. Yeah. We have an early adopter program in Red Hat for this, you know, OpenStack type stuff. I don't know much about it because I'm not on the product side. You know, if you want it, talk to Red Hat sales, you know, they'll figure it. I'm more on the community side, so. OpenStack deployment. How many of you guys work in places like IBM or huge-ass corporates, you know, like tons and tons and tons of people? No? Nobody? Cool, okay. Places like IBM, you might have seen in the media, they have their own implementations of OpenStack and they do things because they've got friggin' whole divisions, you know, floors full of people to do this and they write their own bits. That was sort of like the early audience for the OpenStack thing. These places with huge amounts of resources that will get into it. We're trying with this new release of RDO, which is what we call it, the community version, this community release, openstack.redhat.com. It's made for people that want to try it out on a CentOS or Scientific Linux or RHEL platform. Try it out, have a go. It sets everything up in one box. You know, it's options to scale it out more than that. You know, but you get the web interface, you get all the APIs, you get everything. You know, you can run it pretty easily.
I also get it for Debian.
I'm pretty sure Debian has its own version already, like DevStack and TriStack and these other things. So we've got a thing called PackStack, which is the CentOS version sort of thing. But I mean, if you want to port it to Debian, go for it. You know, Upstream will accept contributions. All cool.
It's based on the Puppet module, so it probably works on Ubuntu and then.
Wouldn't surprise me. So, yeah, okay. Well, there you go. So, good question. So, I think you've used Debian and Ubuntu before, yeah?
Sorry?
Have you used Debian and Ubuntu much?
A bit, yeah.
Yeah, okay, it's just a question. So that might be more your kind of thing if you want to try it out and, you know. So OpenStack releases. As you can see, it's only been releasing stuff for a few years. The release cycle for OpenStack is every 6 months, major release. So we had a release about 2 weeks ago. I think it was the last, maybe 3 weeks ago, was the last OpenStack release. That was Grizzly. And each release for the past couple of years, you'll see different things happening. So this release in Grizzly was where we got the Gluster FS drivers in, where Heat, that orchestration thing, got into incubation. There's a project called Ceilometer, which is like metering and billing. So people that want to internally, measure how much particular groups of users have used stuff so they can bill internally or bill externally. Ceilometer is a project for doing that. I haven't touched it yet, so I can't really sort of give demos or say much about that. But yeah, so those projects, Heat and Ceilometer, are in the Grizzly release as incubation. The next release, they've been accepted into the next release, Havana, in about 6 months. They'll be, main projects, not incubation projects. Launched yesterday, literally about 18 hours ago now, this RDO thing. RDO is the Red Hat version of OpenStack Easy Installer. It's, you literally go to OpenStack at redhat.com and 3 steps to install. It's for Red Hat Linux, Enterprise, any of the derivatives of Red Hat Linux. You'll have seen, or maybe have noticed previously, that Red Hat's been a bit like, meh, towards things like CentOS. It's just, Red Hat as a company is not a single culture. We have different teams that do different things. Some of them love CentOS. I'm on the fan of CentOS side because it gets our stuff out there. some of the teams aren't. So this is by a team that's very CentOS happy. So I know for sure this runs on CentOS because I run CentOS on a lot of stuff to make sure it works. Released yesterday at the OpenStack Summit. If you happen to be running Fedora 18 or 19, it will work on that. But, its main thing is CentOS. There is a quick start on there. It's 3 steps. It's literally cut and paste. So if you've got a CentOS box or a roll box, you literally cut and paste. Yum install this, yum install that, do that, done. Give it 10 minutes. It installs everything. And then you can log in to the Horizon web user interface and you're all good. Yeah, I'm getting towards time too, so not too bad timing because we're nearly at the end. In fact, I'm going to be 8 minutes early. So, useful links. So RDO, openstack.redhat.com. You take a look. It's got forums. It's got quick start instructions, links to other things. Links to the docs like how to integrate GlusterFS if that's your sort of thing. If anyone wants to write docs up on how to integrate Ceph with it, friggin' anything, write it and put the link on there. It's all good. So community-oriented site. The main website for OpenStack is that, openstack.org. Proper upstream for OpenStack is on Launchpad, which is the Ubuntu Launchpad sort of web platform. And there's an IRC channel on Freenode under OpenStack. That's the end of that. Does anyone here have questions? Yes? No? Oh, come on, someone must have a question. Okay, a question.
Can I use OpenStack across multiple data centers?
I am pretty sure that the most recent release of OpenStack allows you to do that now. There's a thing called cells, which is previously scalability for OpenStack was it would scale to tons of machines in a data center, but my understanding it wasn't so good at managing all of them from one spot, whereas the recent release compartmentalizes data centers into something called cells, which is specifically so you can manage across data centers from one spot. I don't know any more detail than that, but as over the years, as OpenStack has gotten bigger and bigger, people are starting to actually fill in the blank spots where it's not been such good, and that is one of the things that people have said needs to get better at that, and so people are working on it. So take a look at it. I know the capabilities in there. I don't know how mature it is. Cool. Anyone else have good questions, interesting questions?
Do you know something about any, I think this is kind of optimistic about some live CD or something like this RDO where I can just boot up a small tiny on a single server installed OpenStack which is using my physical hardware there? Just for tryouts.
Now this particular thing here, this RDO thing, it's made to, you install it on bare metal or virtual machine or whatever. It does everything and sets everything up on one box. So it's all.
If I install it within a virtual machine, I think it's kind of hard to spawn up a new virtual machine within the virtual machine.
Yep. If you can do nested virtualization in your virtual machine, it does work. If you can't do it, that's not going to work. You have to do it on bare metal. So I don't know of an easy way around that. Most hardware these days, if it's reasonably in the last 2 years, will do nested virtualization if the software supports it. The KVM software here, if you're running CentOS, I know does. I haven't tried it with some of the other variants, but, try it out. There isn't an easily downloadable VMware image or VirtualBox image or anything yet. If you want to make one and chuck it up, we'll probably link to it.
This will do.
Okay, cool. So, it's all good. Yeah, look, if you want to do stuff with the Django interface, you'll find the community is actually a really responsive community. In the IRC channel, if you jump in and you ask questions, or the mailing lists, these guys are really helpful. It's as long as you're in the same sort of time zone as these guys, and many of them are in the UK, London, and US time zones, you're cool. If you happen to be in Australia, like I have been, because I'm an Australian, that can get more interesting. You start doing the whole midnight shit. It's a pain in the ass, But if you're in the similar time zone, you're sweet, right? It's all good. Well, I think that wraps the presentation, and Okay, thanks, guys. Cool. Who's asleep? No one that puts a hand? Anyway, cool. Thanks.
Okay, thank you, Jeff.